Today we will learn about asynchronous programming in JavaScript by learning about how the task queue works and the event loop and web APIs. We will also learn the problems of nesting too much callbacks that will result in the callback error, and we will learn how to fix that using promises. And finally, we will improve our code to use one of the best keywords that are called async and await. Because as you know, JavaScript is a single-threaded language and it runs synchronously, which means it executes code step by step. So if I have these three instructions right here, all of them are just console login. So if I execute this, say node my script, it executes just as we read it: start, middle, and then end. But what happens if I use, for example, a set timeout in here, and I provide a callback that will hold the middle console log? So if JavaScript is completely synchronous code and runs only synchronous code, what is supposed to happen is that we see start, and then we wait 2 seconds, we see middle, and then we see end. So let us execute this and see the rules. So it says start, end, and then we wait, and then we see this middle. So what is actually happening? So in the first example, the execution was fairly simple and JavaScript was really synchronous. So we got the first instruction gets pushed to the call stack, it executes, it console logs start, and then it gets popped off the call stack. And then we got the second one executing, so it is synchronous step by step. We get the message middle, and then it gets popped off the call stack, and finally end, push to the call stack, execute, displays the end in our console, and gets pushed off the call stack. But in the second example, where we had the set timeout, something was a little bit off. So we got our set timeout and we have a callback. So we got the first console log executing, and then it executes, display starts in our console, and then it gets pushed up to the call stack. And then it appears like the second instruction was skipped. So from our perspective, that's what appears to be happening in the call stack. And then we got this third instruction is executing, it gets pushed to the call stack, and then this one hanging outside, and then it executed this one, so it displayed end, and then we got our set timeout gets pushed to the call stack and executes our callback. But the reality is really different. The reality is that JavaScript was still consistent, so it was executing code synchronously, step by step. So it executed the first console log, it displays start, it gets pushed off the call stack, and then when it reaches set timeout, it says, look, this set timeout, it could be a long running operation, it could actually freeze execution, and since I'm just a single threaded language, this might give a bad user experience. I mean, what if we have 50 seconds waiting, so I can't execute anything until 50 seconds elapsed, and then I get to execute? So that seems like a lot. So in JavaScript, we have two types of operation. We have long running operations, such as set timeout or set interval, or even event listeners. I mean, imagine if you have add event listener in here, and you will wait forever until the user clicks on the user interacts with that event to execute, and then you will execute the rest of your code. What if that is like maybe 2 hours? So your website will give really bad user experience. That's why there are two types of operations. There are long running operations, such as set timeout, set interval, add event listener, reading from disk in the case of Node.js, because it has access to your file system. And there are simple instructions, synchronous ones, like console.log. So they don't take a lot to execute. So what JavaScript does is that it actually pushed this to the call stack and said, look, I'm gonna push it off, but this time I'm gonna need the help of another component, my friend right here called web API. And then it schedules this set timeout, so it calls it from this web API. So this web API is just a component that is part of your runtime. Your runtime has something called web API where it has all the methods that extends JavaScript. And this web API executes in a completely another thread. And then the engine continues execution. So it executes this console.log and gets pushed off the call stack. So the management of this method is not done by the main thread. It is done by another thread using web APIs. And then, so the management of the delay and the set timeout is managed completely by this one. And after we have our timeout reached or elapsed, it will register a callback in what we call the task queue. So this task queue is another data structure, and it is of type FIFO, which means the first element that gets in will be the first element that gets out. And it has callbacks. So all of these methods will actually register callbacks after some time. And when they register them, they put them in this task queue. And inside this task queue, there is a mechanism called event loop, which is simply waiting for messages to get in. And then the first message that gets in will get out. But in this case, we have just one single callback. So let us delete these. So we have one single callback. So the event loop will listen in this task queue, and it got the first callback, which is from this set timeout after 2 seconds, and it gets it out, but it puts it into the call stack, which is the main thread. And then we get finally our callback executing, and in our callback we just have a simple console.log which says middle. So that's what actually happened under the hood. And that's how JavaScript achieves asynchronous code. Okay, so now let's take a look at an example of asynchronous programming with using callbacks. Okay, so let's say, for example, I have a server and I want to fetch some information from that server using this function. So I have a simple function called getInfo, and it will take a username, and let's simulate fetching, the operation of fetching from the server using set timeout, because that operation is obviously asynchronous, so it runs in the background in another thread. It fetches the server, then you could do whatever you want, and meanwhile it doesn't freeze your code execution. And after you get the information back, you execute something else. So let's simulate this by using set timeout. So I have a callback, and inside the callback, let us say that we got our information from the server. So we say return, and we will return an object that has a name and it has an email. Okay, so the problem with this approach is that I can't have access to this object right here, because I can't just simply say let user information is equal to get info. So my get info doesn't actually return the user information because it is executed asynchronously inside set timeout. So the solution would be to actually pass a callback to this get information. I would first of all pass the username, and then I pass a callback. So let us simulate this. So I have in the second argument a callback, and I will call that callback whenever I get the user information. So I call your callback, and I will provide you in arguments your user information, which is this object right here. So, and now since I have a callback, so I have the user information passed as a parameter. So the one that is calling this callback is this set timeout method. And then I can do whatever I want with my user information. So let us console log the user information and execute my script. It executes directly. That's because I didn't pass a timeout to the set timeout. So if I say after 2 milliseconds, console log the user information. Now it waits 2 seconds and then we get the information. So this is really similar to fetching information from a server. But what if I want to do something else? What if I want to get the user, for example, subscriptions but only after I get the email and the name? So I would create another function that would simulate get subscriptions. And inside the subscriptions, it must take the user information. So this method get subscription is dependent on this one, get information. So you can't directly execute get information without having the user information. So we will say get subscriptions. And then we will simulate getting those subscriptions again by using a set timeout. And we provide a callback. So inside this callback, we will just return the user subscriptions, which is simply an array. So let us declare an array, call it subscriptions. So we have 1 and then 2. So just an array of string values. And then we will call your callback that you will provide us, obviously, because again, there is no other way of retrieving those information without a callback. So I will say I take that callback and I will call your callback finally after, for example, 2 seconds. And I will provide you with the subscriptions. And what you will do is that you will nest. So inside your callback, you would provide another callback. So we would call get subscriptions, and you will provide me with the user information because I need that. And you would provide me, and then since you know that I'm gonna call your callback with the subscriptions, so you have subscriptions available as parameters. And then you would do something. So I can console log the subscriptions for you. So if I go back to the console and execute my script, I wait 2 seconds to get to the information. Then I wait 2 other seconds to get the subscriptions. Okay, so our code is starting to get ugly. So what if I have another method, which is get let's say, for example, get videos. So each subscription has videos. So I need the subscription. I need 1 subscription from you. And again, in order for you to get the videos, you will provide me with a callback. So what I would do, I will simulate getting videos, which is fetching from the server again by the set timeout. And after some timeout, 2 seconds, I will give you another array, which is videos. So let's say let videos is equal to, and this is another array that contains, for example, this time just numbers for the sake of simplicity. And in order for you to get those videos, I will call your callback and provide an argument to those videos. So what you would do, you would again say, look, after I get the user information, I need to get the subscriptions, and after I get the subscriptions, only then I can get the videos. So if I get the videos, I will pass it the subscriptions. So pass in the first subscription, and then I know that you're gonna call my callback with the videos, so I have access to those videos inside that callback. And let me console log the videos. So if I save and re-execute, I will wait 2 seconds to get the name, and then 2 seconds to get the subscriptions, and another 2 seconds to get the videos. But look at this ugly code. So this is a callback. So this one is a callback that is nested within another callback, which is this one, and that is nested within this callback, which is this one. So this nested callback is what we call callback hell. Imagine you do this for a really large operations, so you can get the information, the subscription, then the videos, then the people who like that video, and then the profile of that person who liked that video. So it will be a callback inside a callback inside a callback, and you will quickly lose track of your code and you cannot maintain it anymore. So that's why they call it callback hell. So it would look something similar to this one. We've got a callback inside a callback inside a callback inside a callback, and you will get this weird thing right here, and you would start, your code will start to look something similar to Lisp. Anyways, so this is really ugly, and this is what we call callback hell. So in a nutshell, the real problem with asynchronous programming in JavaScript is that the only way to get the results of an asynchronous function is by using callbacks. So you got an asynchronous function, and the way you get the results from that function is by providing a callback, and that function will call your callback by providing the results as arguments. And that will eventually lead you to callback hell. So how do we properly write code that is more readable and more maintainable when dealing with asynchronous programming? And the answer is by using promises. So a promise is just a built-in language feature of JavaScript that makes handling asynchronous code easier and more readable. So consider the following aspects. We have two types of code. We have a producing code that does something, for instance, fetching some user data over a network. So in this case, this is a producing code. So it fetches data from the server, gets user information, and we are just simulating that by using set timeout. And we have a consuming code, which is the code that takes the result from the producing code and do something with it. So it consumes the results of that producing code. In this case, the consuming code is the callbacks. So these callbacks are the consuming code. So they take the results that you provided as arguments inside your producing code. So your producing code will call your consuming code, which is the callback, and will provide the result as arguments to your callbacks, to your consuming code. So in a nutshell, there are two types of code, producing and consuming. A promise is a special JavaScript object that links the producing code and the consuming code together. So the producing code takes whatever time it needs to produce the promised result, and the promise makes that result available to the consuming code when it's ready. So it says, look, give me your code that is going to take some time to execute, and I promise whenever the result of your producing code is available, I will call your consuming code. So that's why it was called a promise. So the basic way of creating promises looks something like this. So you declare your variable that will contain the object of that promise, and since the promise is just an object, so there's a class called promise with capital P, and as arguments it takes a callback. Now don't worry, this won't become a callback here. So you provide an argument, a callback. That callback is called the executor. So this callback right here for this promise is called the executor, and it's called the executor because the promise will execute this as soon as it creates the object. So as soon as you say new promise, it will execute this executor. So JavaScript will inside this promise right here, there are two functions called resolve and reject, and they are passed to your callback that you provide to this promise. And inside this executor, you will provide the asynchronous operation, something that's gonna take some time. something that is going to run asynchronously, for example, fetching data from a server, just like we have seen before, getting user information or getting videos, getting subscription. All of them are being put inside this executor. So the code will run asynchronously, or in other words, you would put the producing code that would produce the result. And once you get that result, instead of calling just user-defined callback, you would call these two callbacks. So that's the difference. You would call either resolve or rejects, and it depends on the result of the asynchronous operation. So if the job finished successfully, you would call resolve, and you would provide its arguments the value, which is the result. And if an error occurred, for example, the server was down and you couldn't fetch the information, you would reject. You would call this the second callback reject, which will throw an error, and you would provide the error, which is an error object. One of the properties that our promise object will contain after we create our promise object are called state and result. So our promise has a state, and initially it is set to the pending state. So it is pending, and it has a result of undefined. So by default, when you create a new promise, it has these two properties with these two values. And then if you call resolve, the state of your promise will change from pending to fulfilled. And then you can retrieve the value. And as I said, then you can retrieve the value. And the result will hold that value. So we'll call resolve value. And if some error occurs, you would call reject. And when you call reject, it will change the state of your promise from pending to rejected. And the result will contain the error. So before we rewrite our code using promises, we need to first get comfortable with them. So we will create a new file called promises.js. And now let us create a simple promise. So promise is equal to new capital P promise. And we need to provide it a callback. This callback is called the executor, and it will be executed automatically just right after we create the new promise object. Okay, so in here you need to provide the producing code, the code that should produce some results. So let us simulate an asynchronous operation that will return us, it will give us back an object that has an email. So we say email. Now the difference is that we don't pass this promise any type of callback, just like we used to do. We used to pass in our own defined callbacks to get the results. But now we need to change the state of our promise. So currently the state of our promise is, as we said, pending. Now we need to change the state from pending to fulfilled. And we do that by using the callbacks that are provided by our promise. So when the promise starts executing our executor, it passes two functions. The first one is called resolve, and the second one is called reject. And the purpose of the resolve is to change the state from pending to fulfilled, and it will provide the result. In this case, the result is this email. So I will just call resolve like this. And if some error occurs, I will call reject. So for now, let us just see how we can work with successful operations. Now what I can do, I can say, hey, promise, do your job, execute my producing code. Then when you finish it, please provide me with the result, and I'm going to give you the callback that you're going to execute, which is the consuming code. So I'm going to say result. So you need to provide the consuming code, and this then method will execute this callback that you provided only when the state changes from pending to fulfilled. And when it changes from pending to fulfilled, as we said, the resolve will also provide the result of this asynchronous operation. So as we said, the promise has two internal properties. It has state and it also has the result. So if the state is fulfilled, I am sure that the result will be this email right here, and then we'll call this callback, providing it with the result. So it calls its internal property result and passes it to your callback. So I can console log the result, and first of all, let us simulate it with 2 seconds. If I open the console and execute my script, it will wait 2 seconds, and there you go. I got my email. For now, we can handle successful asynchronous operations. That's because we are calling resolve. But what if something wrong? What if the server went down, or something went wrong in our asynchronous operation? So let me comment this. I would automatically call reject to change the state of my promise, and I would specifically change the state from pending to rejected, and I would provide the error value. In this case, I will just say, for example, server is down. The way to handle reject is by adding a second argument to then. So the first argument is about providing a callback that will be executed if the resolve was called in the executor. But if the reject was called, we will add a second callback that will handle that case. So we will get the error, and we will just console log that error and execute my script. And take a look at that. After 2 seconds, it says that the server is down. So this then method executes the first argument, which is going to be a callback in the case of successful asynchronous operation, and in the case of failure, it will execute the second callback. Another cool way of handling errors is by using the catch method. So how do we do that? We first of all delete all of this. So we say do this if the asynchronous operation is successful, and then we say dot catch, and now we have the access to the error, so provide the callback. So the promise will execute this callback by providing error as argument, and I can console log that error directly. So this is way much more cleaner than just providing 2 callbacks inside them. But you can choose whichever method sounds good to you. If I execute my script again, and there you go. After 2 seconds, it says server is down. And finally, the best function that I like that promises provide us is called finally. So how do we execute finally? We just press in dot, and then we say finally. What finally does is that it will execute any callback you provided, whether the result was resolved or rejected. So it doesn't matter which function was called, either the resolve or reject, it doesn't matter. You're gonna execute this anyways. So whenever the state changes, it will execute this function called finally. Now I will just console log, and I will say finally I got something. If I save this and open the terminal and execute my script, I will get 2 messages, server is down, and then finally I got something. That's because this finally executes whatever callback you give it whenever the state changes, whether it will be the state changes from pending to resolved or from pending to rejected. So the best part about the then method is that it returns a new promise. That new promise, its value is resolved to the return value that you provide inside the callback. Okay, so this might be a little bit complicated, so I'm gonna explain with an example. If we have a simple promise with a set timeout, just a simple asynchronous operation, that will resolve to this integer 10 after 3 seconds. What I'm going to say, look, my promise, after you finish executing my producing code, then please provide me with the results and execute my callback. So my callback is going to need the results, so you're going to call my callback and you provide it with the results. Inside this callback, I'm going to multiply that result by 2. And I'm going to return the value. The then method will take the return value of this callback and resolve it into a new promise. So the code inside this then method will look something like this, just to be clear. So we have a simple function called then that takes a callback. Okay, so all of this is inside the promise class, don't forget. So we have those internal properties like state, which is going to be fulfilled at this time. So we say fulfilled, and we have the result, which is 10. So all of this is inside the promise object. And now what we can do, we can say return a new promise. Return, and we say new promise. Inside that promise, we're gonna have the resolve and the reject. Okay, so it's just a simple promise. And then I'm gonna open the curly braces. Inside that promise, what I'm gonna do, I'm gonna say let result. So this is going to be the new result. So actually let's call it new result just to make the difference. So I say new result. Okay, and then I'm gonna say new result is equal to, and then I'm gonna call your callback, this one right here. I'm gonna call your callback and I'm gonna provide it with the current result, which is this dot result, which is this one, 10. So I'm passing 10 to your callback and I called it, and your callback returns something. So it returns result multiplied by 2. So it should be 20. Okay, what I'm gonna do, I'm gonna resolve the new, I'm gonna resolve to the new results. You might be saying, why all of this mess right here? So all of this is basically abstracted away from you. So I just explained this for the skeptic. So the code look approximately like this. It's not 100% like this. Of course, the code is really more, a little bit more complicated than this one. It can handle more use cases. So it's not necessarily like this, but I just did this so you can get an idea. And the cool thing is that you will have the power of method chaining. So you can say dot then do this, then after you finish that dot then do this, because this one will return a promise. Okay, so I can say dot then, and I'm gonna take that result, which is the new result, which is 20, and I'm gonna console log it, and then I'm gonna multiply it by 3, and this one is gonna return a new promise, and so on and so forth. So I can have this chain of asynchronous operations, and all of it is abstracted away with the help of promises. So that's the cool thing about promises. Okay, so now let us rewrite our ugly code using promises. First things first, go to wherever place you have asynchronous code and return a promise. So I say return new promise, and inside the executor, of course, you're gonna have two callbacks, resolve and reject. That belongs to the promise. And now take this producing code and put it inside the promise. So you're gonna execute this asynchronous operation. And instead of calling this dirty callback, I'm gonna call resolve. Okay, so I'm gonna resolve to this awesome object. So essentially I'm saying after 2 seconds, change the state of this promise from pending to fulfilled and put the result as this object. Now let us test this. So I can delete all of this and I call get info, and I'm gonna say get the information for this guy called Ezio. Only then, when you finish doing that, please execute this code right here. And would you please, when you execute my code, could you please provide me with the user information, because I know you got it. And I'm simply gonna console log user info. Open the console and execute the script. 1, 2. Now I got the user information. So for now, you don't see the full power of promises. So let us take this one step further. What I want to do, I want to call get subscription after I get the user information, and I want to provide it with user info. Okay, so that's what we have done previously. So first of all, let us remove these curly braces for now. And I already know that the then method will always return a promise. Okay, so far so good. So then will always return a promise whose result will resolve to the return value of whatever you provide inside this callback. And inside this callback, I'm simply calling get subscription. So it would be great if get subscription also returned a promise like this. I can say return and then new promise, because it's also it has a synchronous operation. And inside the executor, I'm gonna just take this and put it in here, and inside of calling this dirty callback, we're gonna resolve the value to this array subscription. Now what happens is that I can say dot then. Now I got the subscription, so I can say subscriptions, and let me console log the subscriptions just to be sure. Say subscriptions. Re-execute your script. Now 1, 2, 1, 2, so 4 seconds, and there you go. I got the array of subscriptions. So what happened under the hood is that this .then method was really smart. It says, look, I'm going to return a new promise, so you can chain whatever you want to do. And I'm going to resolve the result of that promise, the new promise that I'm going to return, to the return value of this callback right here. And since the return value is going to be a promise, I'm just going to return the full promise that you're going to provide. So it automatically knew that I'm returning a new promise. So it said, okay, just return the new promise. And that's why I could say .then, and that's new promise. Its value resolved to this array subscription. So I can have this beautiful code right here. Now I can take this even one more step, and let us delete this ugly code. And then I'm gonna say get videos. So essentially you can read the code. It's closer to English. You're saying get information of Ezio. Only then get the subscription with this user information. Only then, after you get the subscription, you can get the videos. Which videos of these subscriptions? Okay, so but I need to first change this into a promise. So I can say return a promise, and I'm gonna say resolve and reject, and take the code right here and put it in here, and then change this callback and just resolve. Okay, so now what we can do, we can console log this. So let's just simply console log the videos in here. So save and go back. So now how many seconds is gonna take? It's gonna take 2 seconds to get the user informations, and another 2 seconds to get the subscriptions, and another 2 seconds to get the videos. So total of 6 seconds. So let us start counting. Re-execute your script. 1, 2, 3, 4, 5, 6, and there you go. I got my array. Now look at this beauty right here. So look at this code. It is way much better than that callback here. So you can, that's why I told you before that there's a great power in that method chaining that is provided by then, and it all happens because then always return a promise, and when it sees that in your callback that you are already returning a promise, it will automatically return that promise. So that's why you can say dot then, dot then, dot then, and so on and so forth. Okay, so far this code looks great, but wouldn't it be even better if we had something that looks like this one? I mean, is it really that hard? Well, actually, it's not at all with JavaScript. So remember that the problem in the beginning is that we couldn't access the result of an asynchronous operation, and we can access it only through callbacks. And so that's why we can't do something like this. But with the help of two new keywords that acts as a syntactic sugar over promises, we can achieve something similar to this. First of all, create a function. Let us call it display video, since it is the final task that we will do, and put this code inside this function. You need to declare this function as asynchronous by saying async, and then whenever you have a function that returns a promise, you can say await. That will look something similar to this one. So this user information will be put inside this variable right here. And then I'm just taking the subscription that will be returned to the promise, and I'm putting it inside here. So it's as if I'm saying dot then, and I'm taking whatever the rest of my code until I reach the last curly braces, something like this. So it's just syntactic sugar over promises. Okay, so whenever you have a promise that returns a promise, it could be awaited. And in order for you to use the await keyword, it needs to be put inside an async function. Now, let us console log the videos. Okay, videos. And now call your function. You can say display videos. If I save, then open the console and re-execute my script, after 6 seconds, I should get the videos. And there you go. I got the videos. That's because I'm console logging 2 times. The first console log is inside these videos, and the second one is inside here.